Hi, I'm an old guy and I do maths. Here we have a problem that a student of mine was given. She was asked to find these two angles, theta and phi, in radians, which was an interesting take, and also how long b, that's not a 6, it's a b, how long this side is. We'll do the second part first because that's fairly straightforward. It's a bit of Pythagoras. 9 squared minus 7 squared is going to equal b squared. 9 nines are 81, 7 sevens are 49. 1 from the other leaves us 32, and that is equal to b squared. So b is going to equal the square root of 32. If you want to see that as a decimal, it's going to be 5 point something. Let's just find it for you. 5.666, something like that. There we go. I don't know what the units are. It's 5.66 units. Okay, well that's out of the way. We don't need this to solve for these two angles. Let's take theta first. So we've got the opposite, we've got the hypotenuse. So we can use the sine of theta is equal to 7 on 9. And we pop that into the calculator. And I'm going to do this in degrees and then I'm going to convert to radians. So sine of 7 divided by 9, that gives me 51 and some degrees of change. So 0.057, get that round the right way, 0.05755.873, and I normally round, especially when I'm demonstrating, but what I want to do now is I want to convert this to radians, and the easiest way to do that is to multiply this number by pi divided by 180. So you can see that, hopefully you can see that happening on the calculator there, rather than put the calculator into radians. And what that gives me is 0.8911 radians, which kind of makes sense. 1 radian is about 57.1 degrees. We're getting up towards 0.9 of a radian, 51 degrees. I'll certainly buy that. Now, similar process for this, except we're going to use a cosine, and we've got the adjacent over the hypotenuse, which is 7 over 9. Okay, so and for that I get 38.94244.127 degrees. Those are both degrees, by the way. And I'm going to multiply that by pi on 180, and I'm going to get 6797 radians. And there we are. That's how that is done. Really straightforward stuff on a calculator. You don't necessarily need to put this thing into radians, or indeed do the working in radians. You can, if you're comfortable with degrees, the real trick is to get as many decimal places as you can, and that improves the accuracy with the radians. But anyway, that's that problem. That's that problem done. If you had really felt like it, you could have used a tangent for each of these, because we do know what this side is. We're lacking a few decimal places here. Again, what I would have done is I would have run this out to 8 or 9 decimal places to improve the accuracy. I might actually do that and just see what. Let's just see what happens. We'll try one of these angles and see how far we are off. So let's find. Where are we? We'll do this one. 7 over 5.666, whatever it is. So 7 divided by, no, let's go straight to the tangent. We'll do it here. 7 divided by 32 square root thereof, and we get, we get exactly what we did before. We get this. So again, that's utilizing as many decimal places as I could get. I actually did 7 divided by the square root of 35, which would have included all the decimal places that I could possibly get on this calculator. So anyway, it's a check, and it shows you, first of all, that this was right, and secondly, that was probably right. Okay, well, thank you very much for watching. I do hope you found this useful and interesting. If you did, please like and subscribe, and I'll see you next time. Bye.